Welcome. This video is going to explain the external calibration workflow in time-of-flight single particle investigator, or TOF SPI. We're going to start by installing the software. Unzip the TOF SPI installer folder. Open the folder and double-click the Setup application. Follow the instructions in the installation application to install the software. Once the installation is complete, the software can be found on your desktop in a folder called TOF SPI. Open Step 1 of TOF SPI, entitled Background LCs. Go to the File folder and open up the external calibration test files. Open the sample files and click OK. Select the All Files in Folder button. This will process all the files. In the blue box, load an isotope list. Click the Load Isotope List from text buttons. Alternatively, you may drag and drop the isotope list text file into the file path for TOF SPI. Since we are analyzing single particles with external calibration, please select No Droplets Single Particle Full Time Trace from the drop-down menu. Our JSON file is in the folder with the single particle files, so we will use the Auto Find JSON option. Run the program. When the arrow turns from black to white, the program is finished running. Select the M to Z critical value expression button. For our SIS data, the min events should be set to 0.02 and the max events to 0.075. Default values are 0.005 for minimum and 0.075 for max. The average SIS data from the filtered data should plot, displaying only the M to Z's from your SIS calibration. And you can adjust the min and max event rates and rerun the program to adjust the M to Z's for the SIS histogram for critical value determinations. Run the program again and make sure all parameters look correct. Now select the Background TOF Counts Value tab. On the Background TOF Counts Value tab, select the All Parameters Ready Set button, Ready to Run Background Fitting button, and the Write Info to HDF5 button. Run the program again. When the program is finished running, ensure that all HDF5 files have an updated timestamp. You will need to repeat this process for the reference particles used. When using external calibration methods such as a calibration curve, you will need to use Step 2b, TOF SPI Liquid Quant. On the first tab, you will first define and upload the standard reference particles that will be used to determine transport efficiency. First, fill out the information on the standard particles used. Here we used 50 nanometer gold reference particles, so we select our isotope to be 197 gold. In this example, our uptake is 45 microliters per minute. We can use the drop-down menu to select our reference particle standard, which automatically fills out the nanoparticle diameter and mass. If you use a different particle type, you can fill in the purple user select box with the information on your particles. Next, click on the file path for the gold reference sample. Upload the HDF5 file. Next, we will move to the red box and input our calibration curve for the standard particles. In this example, we are using a blank and 4 concentrations of gold. First, click on the file upload for the path for liquid calibration files. Your folder should contain all HDF5 files you want to use for the calibration curve, including the blank. Make sure they are labeled in order. If you want to upload a text file that specifies the concentrations of each calibration standard, use the Upload button underneath File Path for solution concentration. Here, our concentration range from 0 from the blank to 4.94 nanograms per milliliter. Make sure that you use this to specify your concentrations, and you select the Import Concentrations from Text File button. Next, run the program to make sure all files load correctly. In the top, you should see a time trace in nanoparticle references and the count histogram. Check that the blue and red lines are set properly, bookending the particle count distribution. If the distribution is not Gaussian, you can run the program again after deselecting auto threshold above the reference particle time trace. On the bottom red box, you should see the time trace of each calibration standard and the calculated Q plasma and transport efficiency. On the next tab, Liquid Quant Detection Efficiencies, we will first input our calibration curves for the particle samples under Path for Liquid Calibration files. These files we are using are under our multi-element or ME calibration curve folder. Once uploaded, we can similarly upload the concentration text file like we did on the first tab. Make sure to select Use New ME Concentration button. If these concentration curve samples were run at different uptakes than the rate from the reference particles, make sure to set a new uptake. Otherwise, this will auto-populate with the uptake rate set of the first tab. Our data was ran at 45 microliters per minute. The last step on this tab is to load isotopes that will be used for quantification. This means all isotopes specified here must be used in the multi-elemental calibration solution. After uploading, make sure the button is selected, Load Isotopes. Click the program again, or run the program again to check the time traces. And use the drop-down menu to select a specific calibration plot. Make sure once selected to run again. Check the absolute sensitivities that populate on the right side of the screen. Finally, on the third tab, called Nanoparticle Sample Conditions, upload all particle sample files. Again, if the flow rate is different, adjust this. Run the program to make sure the files are loaded correctly. And then select the button for writing solution calibration to HDF5. Run the program one final time. You can now move on to step 3. Open step 3 of TOF SPI, entitled TOF SPI Particle Quant. On the first tab, go to the test data folder and find the sample files and load this file path. Select the Use All Files and Folder button. We will use the default rates for the dynamic critical value parameters. Run the program. Make sure the data loads correctly. The calibration approach box should say conventional, and all the tables in the data from previous processing steps box should now be populated. If the data does not load correctly, there is an error in processing the data in the second step of TOF SPI. Go back to this step and try again. Go to the second tab entitled Split Event Correction / Element Mass Calibration. From the drop-down box, you can select the type of split event correction. For this, we will use multi-event. Run the program. On this tab, you can have a look at the signals and mass histograms for elements in your sample. Only the last data file you load into the program will be visible. If you want to look at data from a specific file, then load that file into step 1 and deselect the Use All Files and Folder button. Navigate to the third tab, entitled Particle Signal Viewer / Particle Number Concentrations. Have a look at the data displayed on this tab. It can be especially useful to look at the particle time traces. Navigate to the fourth tab, entitled Report Settings. Select the reports that you would like to export. Here we will select the Excel report, the TOF TOF Pilot Format Report, and the Machine Learning Report buttons. Run the program by clicking the white arrow on the top left of the screen. When the program is finished exporting data, it will be written into the same folder where the HDF5 files originate. Thank you for choosing TOF SPI for your single particle ICP-TOFMS needs. For further information on the capabilities of this software, please refer to the user's manual.